Hello, everyone. I hope you are all well. So, I'm going to be looking at Learning Unit 8 today. There are a couple of examples on the slide, but I'm actually only going to be working with the first and second one, and then the fourth one here. You can also try out on your own number 3 and number 5 that you see up on the screen. So here it says to you, and remember this section is based on hypothesis testing. So in terms of hypothesis testing, you are either working with a mean, and if it is a mean that you're working with, then how you can identify that is they would use the word average, and you also have a standard deviation. If you're working with a proportion, because you can also try out, you can also have a hypothesis test for a proportion. You're looking for a percentage, or they'll say so many out of so many. So now let's have a look at the first question and help ourselves identify what you are working with. And also, you will have different scenarios under your mean where two different tables are being used. I will show you which those are, and also you will need to know the values on the one table. I will show you which table that is, and then the other table will be provided to you in your formula sheet. So let's get started with this one. So it says to you that the CEO of a large financial institution claims that on average, so the word on or the words on average is the same thing that we're looking for to tell us that we're working with a mean. So we know it's a mean that you're working with. So they are claiming that on average, their clients invest more than 55,000 per year in a particular portfolio. So here for your null and alternate hypotheses, which is step one, if it's saying more than 55,000, and if you write that out, it says more than 55, that symbol does not have the equality sign. So it cannot go into the null, it must go into the alternate hypothesis. And your null must say the opposite, which is less than with the equal to sign. So less than equal to the 55,000. Remember, the most important characteristic of your null hypothesis and your alternate hypothesis is that the null must have the equality sign, and your alternate will always say the opposite of what the null says. So here you now have your null hypothesis saying less than equal to 55,000. That will say, because it's an average, it'll say mu is less than equal to 55,000. Your alternate will say greater than 55,000. Then as long as a greater than sign is in your in your alternate hypothesis, as long as there's a greater than sign here in the alternate, this would mean that it's an upper tail test. So once you know that it's an upper tail test, you will draw up your bell-shaped curve. This is step 2, and there is a limit on the right-hand side. So I'm just going to erase that so that we don't have the highlighted bit there. And now remember, they were claiming that their clients invest more than 55,000. So this is where the claim is. The more than 55,000 is here, and I'm just going to write in small that this is where the claim is. So then in terms of your region of acceptance and rejection, everything or anything that is less than or inclusive of that value, that critical limit is your region of acceptance. Anything greater than it is your region of rejection. Now you need to actually write this out in words. So you're going to say, accept the null hypothesis. Actually, what you generally are required to do, you can do either one, but what's preferred is to write out the region of rejection. So you will say, reject the null hypothesis if the Z statistic that you're going to calculate just now is greater than, because that's your region of rejection, is greater than, and now we need to know what that actual value is. So what is the value that we're saying? Reject if it's greater than this. So now you need to look at what your sample size is. If it is less than 40, then you are using table 2 of your appendix. So appendix table 2. And this is, sorry, let me just take out that sign here. Okay, so appendix table 2, I think it's page 508, if I'm not, no, 507, if I'm not mistaken, in your textbook. This will be given to you in your formula sheet, page 507. If you find that n is greater than or inclusive of 40, the table in your textbook on page 225. This is the table that you will need to know. You need to know all of the values on this table, and that is going to be the table that will be used if you have a sample size that's less than 40. So now you have, they said to you here, test this claim at the 5% significance level if it was found that a sample of 22 clients invested an average of 53,500 with a standard deviation of 2,500. So now, in terms of the information that's given to us, and I'm going to write it down, 500. So now, in terms of the information that's given to us, and I'm going to write it down, the 55,000 was your mu. That's what they gave to you in the opening sentence here. Your sample size was 22. Your significance level, which is denoted by the symbol A, is 5%. Your sample mean X bar is 53,500. And your standard deviation is 2,500. I'm just going to write SD for standard deviation. Okay, so now you have everything you need. The fact that your sample size is 22 means it's less than 40. So this means that it is table 2 of your appendix. It is page 507 in your textbook, and this will be given to you. So now to determine your critical limit, which is the value that goes here, you are going to look at table 2 of your appendix. This is where you get your T limits from. You need two things. You need A, which is your level of significance. We saw on the previous page that that was the 5% that they said here. That as a decimal is 0.05. Always make it a decimal. And then you need your degree of freedom, which is calculated as n minus 1. So n is 22. They said to you that your sample size is 22. Here it is here. And 22 minus 1 tells you that it is 21. That is your degree of freedom. So you are going to table 2 in your appendix, page 507 of your textbook. You're going to read the A value going across at the top, and then your degree of freedom coming down the first column. So I'm actually going to project that for you as well, just so you can look at how to read it off that table. So here is the table. You're looking for 0.05 going across and 21 coming down. So here it is here. I've actually already highlighted it for you. There's 0.05 going across. There's 21 coming down the first column. In line with that, the value is 1.721. So that now is your T limit. So 1.721. And that is the value that goes into this on your table, in your in your diagram. So I'm just trying to skip back to the question. Okay, here we go here. So you have a T limit that is 1.721. And this is also going to go into here. So because it is an upper tail test, it's a positive value, 1.721. And now you're going to say you'll reject if Z is greater than 1.721. Now that you have your region of acceptance and rejection, you can calculate in step 3 your test statistic. If it's a mean that you're working with, the formula is x bar minus mu over your standard deviation over the root of n. So x bar is everything was given to you. So here's x bar, 53,500. Mu is 55,000. Standard deviation is 25. N is 22. So it'll be 53,500 minus the 55,000 over the standard deviation of 2,500 over the root of n, which is 22. And that would give you a Z value of minus 2.81. Once you have the minus 2.81, you are then going to plug it onto your diagram in terms of where it falls. So a negative number would be somewhere on the left. And this is your region of acceptance. So in the final steps, you're going to say accept the null hypothesis, which indicates that. And if you're accepting the null, you're saying the null is true. So go back to your null and alternate hypotheses at the top. You are accepting the null, which means you're saying the null is true, which means that the alternate is false. Null, which means you're saying the null is true, which means that the alternate is false. And the alternate had the claim. So if we're saying that this is false, we're saying this indicates that the claim is false. And that's it. That is all the steps that are required for a typical question. So that's number 1. Let's look at the next one. So here I said to you, I'd also be doing number 2 and then number 4. So number 2 says the shop owner claims that on average, again, the word on average says to us we're working with a mean, an average. They claim that on average, his shop has a daily turnover of 55,000. So he's saying exactly 55,000, not more than 55,000, not less than 55,000, just 55,000. So the claim will say equal to 55,000 in the null, and your alternates will say that it's not equal to 55,000. Then this is a two-tailed test because of the fact that you had the symbol equal to and not equal to in your null and alternate hypotheses. The diagram for that, the bell-shaped curve, looks like this. Everything inclusive of those values, and within that space is your region of acceptance. Everything greater than on this side and less than on this side is your region of rejection. So now we need to know how do we actually write out this region of rejection and how do we determine what those limits are here and here. Now let's read the rest of the information. It says to you that so he claims that his turnover is 55,000. So that 55,000 is the mu value. Then it says that we want to test this claim at the 1% significance level. So A is 1%. If the daily average turnover for a sample of 68 days was 57,750. So your sample mean is 57,750. Your N is 68. That is a sample size of greater than 40. So then you're going to use the table on page 225 of your textbook, not table 2 that I just showed you just now. And then they say assume a population standard deviation of 3250. So your population standard deviation is 3250. So now we have a two-tailed test. We know that our sample size is greater than 40. We need to go to table or the table on page 225 of your textbook to get to these limits. So now on page 225, we need to know the significance level and the type of test. The significance level was 1%. Here it is here. And the type of test is a two-tailed test. We said that here at the top. So that would be two-tailed and 1%. So let's go to the table. I'm going to project it here. You do need to know the values from this table. This table is not on your formula sheet. I have also already circled for you here the relevant values. As you can see, the significance level is on your is in the first column. Your type of test is in the second column, and then your actual limit is in the third column. So if it is, and in this example, it was a 1% level of significance, and it was a two-sided test or two-tailed test, your limit is 2.58. As you can see, it has a plus and a minus sign. This is indicating to you that it's plus 2.58 on the right-hand side and a negative 2.58 on the left-hand side. So 2.58 here, a negative 2.58 here. So to write out the region of rejection, you're going to say that you either reject the null hypothesis here, where your Z value is greater than 2.58, or on this side, where it is less than the minus 2.58 here. Here. Okay, so you will say, or if Z is less than a negative 2.58. So now you're done with step 2. You can calculate your Z statistic. Remember, it's x bar minus mu if it's a mean over the standard deviation over the root of n. All your values are given to you here. X bar, mu, standard deviation, n. So 57,750 minus the 55,000. 57,750 minus the 55,000 over your standard deviation is 2,500. Oh, sorry, not 2,500. 3,250 over the root of n is 68. 250 over the root of n is 68. So this gives you 6.98 as your Z value. You then plot it onto the diagram. It should be somewhere on the right, which is your region of rejection. So now you're going to say reject the null hypothesis, which indicates that, and remember, his claim was that their turnover is 55,000 here. So his claim was in the null hypothesis. So if you're saying you are rejecting the null, which we are saying here, we are rejecting the null hypothesis, then this is saying that the null hypothesis is wrong. And if the claim is there, this indicates that the claim is wrong as well. So the claim is false. And that's it for your interpretation. Okay, so that's the next one. And then the last one is number 3 here. Sorry, not number 3, number 4. So this says to you that a large manufacturing company claims that less than 10% of its customers make a complaint about the company's products. Now, the moment you see that percentage, they didn't mention the word average, they just showed you a percentage. They said less than 10% of its customers complain about the company's products. So this immediately says to you that you're working with a proportion, not a mean. And so when you get to step 3 to calculate the proportion statistic, it's p minus pi over the root of pi multiplied by 1 minus pi over n. So here your null hypothesis and your alternate, they're saying to you the claim is that less than 10% of customers. So less than 10% literally has the less than sign, less than 10. But this does not have the equality sign attached to it. So this cannot go into the null. It must go into the alternate. So less than 10, the null will say greater than and inclusive of 10. And because we're working with a proportion, it must say pi. So pi is less than equal to, pi is greater than equal to 10 in the null hypothesis, and it's less than 10 in the alternate hypothesis. If there is the less than sign in the alternate hypothesis, then it's a lower tailed test. So here, his claim is in the alternate because he is claiming that less than 10% of customers complain about the product. So now when you draw up the bell-shaped curve, it's a less than test or a lower tail test. Your acceptance region is everything greater than or inclusive of this value. Your rejection region is everything less than it. So now we need to know how do we get to that value, that critical limit, and then how we write it out. So here we need to know the type of test as well and your significance level. So it says test this claim at the 10% significance level if a survey found that 29 out of a random sample of 320 of the customers made a complaint about the company's products. So this 29 out of 320, that is the value of P in the formula. So P, and I'm going to write out the calculation here. P is calculated as 29 out of the 320. So this as a decimal, and you can leave it as two decimal places here. This is 0.09. You'll always leave it as two decimal places. So that's your value of P. And then we also see that the sample size itself is 320. So N is 320, P is 0.09, pi is the 10% that they mentioned at the beginning, so 0.1, and that's all we actually need. And your level of significance is also 10%. They said claim at the 10% significance level. So now, and your level of significance is also 10%. They said claim at the 10% significance level. So now we need to look at, and when it comes to the proportion, we are only ever using the table on page 225 of your textbook, the one that you need to learn. So you're going to look at a 10% level of significance, and this is a lower tailed test. So 10% and lower tailed, let's go to that table. I'm projecting it for you. So 10% and lower tailed. Here's lower tailed at the bottom here. 10% lower tailed, your value is minus 1.28. As long as it is a lower tail test, it'll always be a negative value as your critical limit. So minus 1.28 then goes in here and here. You'll say reject the null hypothesis if the Z value is less than, here it is here, minus 1.28. So now you're done with your region of acceptance. You can calculate Z by P minus pi. So P is the 0.09. You need to show the working out of that like I did here. Then pi is the 0.1. N is 320. So it's P minus pi of 0.1 over the root of pi multiplied by 1 minus pi over n, which is 320. So now that gives you as a value for z minus 0.60. So now you have Z, you need to plot it onto your diagram. It'll be somewhere here. And that will say to you that you're in the region of acceptance. So now you are saying accept the null hypothesis, which indicates that and you'll go back to your null and alternate hypotheses. If you are accepting the null, then you're saying the null is true, but the claim was in the alternate. Here it is here. The claim was in the alternate hypotheses. And if you're saying that the null is true, you're saying that the alternate is false. So the claim is false. So you'll say that this indicates that the claim is false. All right, so that is it for today. Please can I ask that you do try out these examples that I did not go through. They are for your own benefit for you to practice yourself. So the ones that you can work through is the one here, number 3, and number 5. So we did number 1, 2, and 4. You can try out number 3 and number 5. Number 3 is dealing with an average, and your sample size is 21. So the formula for your average is, remember, x bar minus mu over the standard deviation over the root of n. Because your sample size is 21, you're working with a t limit, so you will need to go to table 2 of your appendix. That is page 507. Then here for number 5, because you also have an average, you are also working with the x bar minus mu over the standard deviation over the root of n. This is also a sample size of 22, so also the same thing applies. T limit from table 2 of the appendix. You need A, which is your level of significance. You need your degrees of freedom, which is calculated as n minus 1. There are also more examples of it in your slides, so you can have a look at that as well. Sorry, not your slides, in the revision worksheet that I'll be uploading. So you can also have a look at the additional examples there. And there's also additional videos that have been uploaded of this, so please make sure to listen to those. Thank you, everyone. Enjoy the rest of your evening, and I will chat to you again soon.